All right, so it's now time to talk about shortcuts and rules for finding the derivative. And I thought a little bit of context would be good for this video rather than just start the video. All right, so let's think about this question. How do you calculate y prime? Y prime is also known as the derivative. Okay, so here's what we learned so far. I think, in fact, it was in the last lesson that we learned that you find y prime as the limit as h approaches 0 of f of x plus h minus f of x over h. That expression is called the difference quotient. This may also be called finding the derivative through the limit process. And everybody who learns calculus needs to understand this and be able to do it. That's just the nature of calculus. But the truth is, we won't calculate y prime this way very often. All right, but you got to know it nonetheless. It's important to understand that what this does is find the slope of the secant line between two distant points, and then as h goes to 0, it pushes the points together. All right, and it's the rise over the run otherwise, and it tells you the slope of a curve at a very specific point. All right, so that's our first answer. Answer 2, it should be a 2. All right, is that we can find y prime by shortcuts and rules that you'll see in this video and some other videos to follow. Okay? All right, so we'll focus on the shortcuts and rules because although this may be necessary some of the time, it's not the easiest way to do things. All right? Okay, so let's see. Quick review. What's y prime again? If we're going to be talking about y prime and learning the rules to find y prime, what is it? Y is a function or a graph, okay? And y prime is the slope of that function or graph at a desired point, okay? Y prime means way more than that. It's a much bigger story about what the derivative can tell you, but you know, we have to start somewhere, and this is a pretty easy place to start. So I happen to have my grandfather was a mechanical engineer. Here's one of his old textbooks. I happen to have it, and here's a mechanical engineers study how vibrations affect mechanical systems, and you know, the model for that is usually about a spring, you know, because something that vibrates you could compare to how a spring vibrates. So that's the model. And then here are these equations, and you might not recognize it at this point, but these are all derivatives. The derivatives are used to represent the changes that are happening in that system that has springs that are vibrating. Okay, so it's like way bigger than you even know right now, most likely. But for now, we're going to think of y prime as the slope of a curve. All right? Later, as you continue to study math or whatever you do, you'll learn a lot more about it. All right? So, okay, let's start here. Suppose that y is 7 minus 4x. What's y prime? Okay, well, let's take this approach. What did I just tell you that y prime tells you? You know, this is a graph. You could think of it that way. And y prime tells you the slope of that. But what is this kind of thing? This right here, that's a line, right? It's y equals mx plus b. You could say it's y is equal to negative 4x plus 7. That is a line that has a slope in particular of negative 4. Well, if y prime tells you the slope of y, and I'm reading right out of that equation that it's a line that has a slope of negative 4, the slope is negative 4 everywhere. Does the slope of a line change from point to point? No, it's the same everywhere. So y prime will just be negative 4. All right. So I guess you could call that a shortcut. That was pretty simple. And let's even extrapolate a rule from that. Okay? So if your y takes the form of mx plus b, right, given that it's a line, right, y equals mx plus b is the equation of a line, then y prime will just be m. It'll just be the coefficient of the x. Okay, so that's a rule that you can use as you see fit if you're in that circumstance. What about this one? Y is equal to 4. What's y prime? Well, so let's try to think about it the same way, all right? What is that? When I say y equals 4, just geometrically, what do I have? All right? Like here, I was thinking about that not as an equation, but as a object that has a geometry to it, a line. And so I'd like to look at this the same way. Well, for equations of the form y equals some constant, those are horizontal lines. Okay? And in fact, this would be a horizontal line where every y coordinate is 4 on that line. Okay, well, y prime tells you the slope of y. What's the slope of a horizontal line? A horizontal line is flat. It has no elevation to it at all, no slope at all, okay? And so it has a slope of 0. All right, that's the nature of a horizontal line. So, well, y prime would have to be 0 if that's the information that we get out of it. If that's what it's supposed to tell you about y, then it has to say y prime is 0, okay? So we can think of another rule then. Rule, okay? If y is equal to c, okay? And I'll just say that c is a constant. Well, not just, maybe be more specific. Any constant, all right? Then y prime will be 0. So when you see like constants by themselves, you could think that the derivative of that is 0. The derivative of a constant is 0. Just like this one. But we got some reasoning to understand why that's the case. All right? All right, let's look at something else. Now here, this involves a little more thinking than what I just showed you, but I think that you're up to it, all right? So suppose I tell you that y is x to the third power plus 4, and I say, what's y prime? Okay? I haven't given you a rule for that one yet. But say I tell you a hint, and I say hint. If y is x to the third power, y prime is 3x squared. So what's the difference between x to the third power and x to the third power plus 4? If you were thinking about this in terms of geometry or in terms of a graph or something like that, you would say this graph has the same shape as that one. It's just that this one has a vertical shift up of 4 spaces. Now, what do you think? Say you had some curve, and say you took the same curve with a vertical shift. Would that change the slope at any point? Like, take that point. See that point right there? Is the slope there any different than the slope of this related point on the curve that shifted vertically? It looks same steepness, same slant, same inclination, same slope. And look at this point and the one above it, same slope. If you took a curve and you shifted it vertically, it's not going to make the curve more or less steep at any of the related points. It's just not going to change it, all right? Hopefully you can see that from my picture and you become 100% convinced. So the vertical, if you happen to know the derivative of some curve by itself, say x to the third power, that's a vertical shift of 4 units upward. Any vertical shift, upward or downward, would not change the slope of the curve, all right? There's my sketch to tell you that, or you can see it. This is not the graph of x to the third power, but, you know, whatever. If there's a vertical shift, it's not going to change it. So y prime's the same, okay? Between two curves whose only difference is a vertical shift somehow up or down from each other, then they have to have the same derivative, because the derivative, again, tells you the slope of the curve, and the slope at the curve of these two, point for point, is no different, all right? Okay, so that's for vertical shifts. Horizontal shifts, well, yeah, if I shifted the graph horizontally, that it wouldn't match up the same way, right? That would change the slope at the related points, all right? Okay, so let's look at like our first like kind of broad and formal rule. Okay, so look at this one. Here's a rule for you. This is the one that we'll use most often. It says if y is x to the power n, y prime is n times x to the power n minus 1, and n is a constant power of any kind. Any constant. It could be a negative number, a positive number. It could be a rational number, a fraction. It could be an irrational number like pi. I mean, it does say any, all right? So that's pretty broad. Whatever you want that power to be. Okay, now so I thought, well, let's do this one. You know, this one back here, I gave this to you as a hint that if y is x to the third power, y prime is 3x squared. Well, I guess now we're in the position to pretty easily find that out ourselves, all right? So let's see. The rule says that we'll take this power, so the power's n. It's going to be, so there's my n. 3 is the power. I'm going to get 3 times x to the power 3 minus 1, right? Is that not exactly what that rule says? All right, okay, so hopefully we can agree about that. So it's going to say 3 times x squared. So that's how I got that. All right, now if you have something that, you know, you've got a number, or you've got x and the power is a whole number like that, then it's probably no big deal. If it took the form like this, or this, or this, there'd be a little bit more to the details, but still we can use that rule. Okay, let's try, given that this is the rule I gave you, let's try to do this one. What if y is equal to root x? What's y prime? Well, our rule says that we have to see the problem as x to some power, okay? And then I have the root x there, and the power is not obvious. There is an exponent there. In fact, it works like this. Let's see. Let's do like this. X to the power a over b, a fractional exponent, okay, can be seen as the b root of x to the a power. So I'm seeing something kind of like this, and I want to see it like that. I see a root, but I want to see a power, all right? So in our case, like if you said, well, I've got the square root of x to the first power, is that not true? Yeah, that's the square root, and that index is 2, even though we don't write it in x to the first power. If I had to say that there was a power in there on the x, I'd say it was a 1. So the b's down there and the a's up there, so that's going to be x to the 1/2 power. So we have a translation between roots and fractional powers, all right? So that's the right way to do this one, because I need to see that there is an exponent, all right? So, okay, so let's see. I get x to the 1/2 power, okay? All right, now I'm in the position I need to be in. The power n is 1/2. So y prime is going to be 1/2 x, and then you're supposed to subtract 1 like that. Okay? All right. So that's going to be 1/2 x, and what's 1/2 minus 1? That will be -1/2. Okay? All right. Now, that answer may stand, depending on who you're talking to or what the scenario is, but I'll need to show you a little bit more about that. A negative exponent. You know what a negative exponent means. Isn't it true that we could do like this? Right? Negative exponents have that meaning where this x is technically above the bar at this point. If you really wanted like a deeper analysis of this, I'm looking at this way. Okay, I got a 1 over 2, and is the x in the middle? Well, there's no middle in here. Like every number is either above the bar or below it. So it's x to the -1/2 over 1. If I would like to correct that exponent to positive, I would send it under the bar. It would be down there with the 2, all right? So we could get this. Okay, that's an alternate form the answer could take that you should be familiar with. And then one last form, well, we just learned what these fractional powers represent. They could be translated into roots. So x to the 1/2 power is the square root of x. So I could also write 2 root x. All right. And there are our 3 forms of the answer. And I'll just have to say, be familiar with all of them. I want you to see how I got here initially, how I can translate to this and that as well. All right? Okay, so let's look at another one. What about this one? 1 over x to the 4th power. Now, when we have this problem, are we in the position that we need to be to use this rule? This rule says that you have x raised to some power. It doesn't say 1 over x to a power. So can I alter this so that the rule applies? Well, it'd be kind of like how we treat negative exponents in general. 4 under the bar means a negative 4 above it. So it's like kind of like that. Okay? So there's the bar. This moves up there. What's left? Well, I guess technically a 1. It might be a little silly to write the 1, but if it helps you to see the continuity of it, it's not like whatever's down there just disappears. It's just that it's a 1 and it's not needed. So I get this. The way I need to see 1 over x to the 4th power is x to the minus 4 power. That is the position I need to be in, right? It looks just like that. It's x to a power. The power can be any constant. Okay, so it could be negative 4. It could be 1/2, any constant. So, all right, I've got this the way that I want it to be. Here's what the rule says to do. Negative 4x, negative 4 minus 1. So that is negative 4x to the negative 5 power. That's probably okay. All right? But like this one, there are other forms that the answer could take, and you should be familiar with them. Like maybe we will correct this exponent so that it's not negative. If you want to see how that's done, then maybe look at like this. I've got a 4 over a 1. Let's keep track of where everything is. I'll write the bar. There's a 4 on top of a 1. That's the way I'm going to see 4. And this is an x to the minus 5 over 1. And what do we say that the negative exponent does? It will send this under the bar like that. And then so I got these two fractions. I got 4 over 1 times 1 over x to the 5th power. How do you multiply fractions? Straight across. So you all put it together as negative 4 over x to the 5th power. Okay, so those are the forms that these could take. Now, do you have to write that much detail to figure this out? Well, maybe if it helps you. If it's comfortable for you to do that, then go for it. But, once you get used to the way negative exponents in algebra work, you might jump straight from here to there. That's the real message is I want you to see that we can get from here to there, however that you'd like to see it. Okay? All right, so let's do one more here for this video. This one. What about the 8th root of x? What's y prime for the 8th root of x? Well, okay, so that would be a lot like this one, right? And this rule would be in play. And so for that reason, I would say, well, this, I'll see it for the sake of what I'm doing as x to the power 1 over 8. It's the same thing. The 8th root of something is the same as that something to the 1 over 8 power. Of course, I'm getting there because my rule demands that that's where I be. Okay? All right. So now that I'm there, it should be straightforward. At least this first step should be straightforward. Isn't that what you do? This power here will go to the front, then we'll take that power, we'll subtract 1. That's definitely what the rule said. From here, then I could see like this. 1 over 8 minus 1. That's 1 over 8 minus 8 over 8. So that's going to be negative 7 over 8. Okay? Which, that answer, that could be okay. It might depend on who's asking you. All right? You should be familiar with the other forms this could take. Couldn't this, by the kind of reasoning I was giving up there, couldn't this be 8x x to the power 7 over 8. If I were to write this without a negative exponent. Same reasoning I've used when I've dealt with the negative exponents in the other problems. One more thing though, I need you to be familiar with all these forms. 7 over 8 power. See this right here? What's x to the 7 over 8 power? It's the 8th root of x to the 7th power. So I could write this fractional exponent in terms of a root in addition to that. So I'll say I'll do it that way as well because I need to, it wouldn't be right if I didn't show you all of them. So that last one is 1 over 8 times the 8th root of x to the 7th power. Okay, and those are 3 forms of the same answer. You know, which one's the right answer? Well, they're all the right answer. It might just depend on who's asking you, okay? If you're doing online homework, maybe it only accepts a certain format. Maybe it gives you instructions and says, give your answer in terms of a root. Okay, well, you give the answer that way. Maybe some other class, some other instructor demands that there always be without negative exponents. Who knows, right? I'll have to leave that for future context. I just, for now, if you can accept that, okay, they're all the same, then you're in good shape.